I want to go look. That's what makes me do statistics, is looking. Yes, beautiful. Love these. Hey, Brittany. All right, let's scooch over here. I want to make sure this works, because I also copied this over here. I did. Good. Why is that doing that? Hang on one second.
Oh, yeah.
Why is it polynomial? No, I want linear. There we go. And I want it to be, yep, that's what I wanted. Good. There we go. Beautiful. Okay. Then we'll come into this in a second. We'll leave these out for now. And I got Doug.
Right.
Hang on, we're going to turn this off for a sec, so the surprise is not lost on you guys. Okay. Back to this. Here is our data. Okay, here's our data that we got. Now, if you notice, Excel is able to find what's called a best fit line. Its idea of what the best fit line should be, and it's right here. Now, how many of you, if I were to go in here and take this line out, there's two of them, I guess, there. How many of you would look at that data and say, yeah, it's linear data? Well, I don't think I would.
No.
Not without more mathematical analysis. And the mathematical analysis does show that it's loosely linear. So, it's noisy. This goes back to Emily's point that in nature there are no real lines. So I said to myself, okay. Let's see what Excel says again. That's what Excel told us it was. That's the equation that Excel says it should be. Y equals 0.3637x plus this y-intercept. So theoretically speaking, this model's a little bit weird, because it says, assuming that the distance from your wrist to your fingertips was 0, you should have a forearm that's 7.86 inches long. Well, that's a little bit weird when you try to apply that mathematics to a human body, right? Right? It doesn't make any sense. So what I decided to do instead was reshuffle this over here, so that instead of, yeah, you can't really see it, this line actually goes through the origin, which means there's no y-intercept. The y-intercept, well, I shouldn't say that. The y-intercept is 0. It's hard to see. When they updated Excel, they changed all my spreadsheets. Let me make these numbers bigger for you. That 20, make this 20 as well. So if you were, here, I'll just do this. Let me just do this, hang on. Format the axis. There we go. Let's set it to 0, minimum 0. Wow, Excel looks completely different now. How do I sit, hey, yes, do that. What if I just do that? Yes, that worked. And then if I set the y-axis to 0. Okay, can you see how the line now goes through the origin? That's what I wanted to do.
What do you mean by origin?
0, 0. The point on the graph that is the origin, 0, 0, where they cross. That's called the origin of the graph. So you got an x-axis and a y-axis. The origin is where they cross.
Okay.
So our data is nowhere near that, because when we have length in our forearm and our wrist. We wouldn't be down here. We're going to be up here. Does that make sense, Amy?
Yeah, I'm just wondering why the highest number isn't where the line goes.
Ah, why? Who wants to answer that? Why doesn't the line go through the highest number? Because, Josh.
Because it goes from the first point to the last point, which is the one that's mostly right.
How about this?
That's why.
It's all good. My question, you said the answer. It's a best fit line.
Oh.
It's a best fit line, right? It's not a perfect fit line. The only way this would be a perfect fit line is if we all landed right on that line. Does that make sense? Hopefully that makes sense. But the trick with it is we're not going to land directly on the line, because if you land directly on the line, then what has to happen? You've heard this joke like 12 times now. Then Harrison Ford has to run from the one-armed man because he killed his wife. Come on now. That's what happens when the data is too perfect. It's got to be noisy. It's got to be. I'm actually surprised that one lands so close to the line, to be perfectly honest. But remember the idea of residuals? These are all off a little bit. That line is the least off of all possible lines we could have drawn. Like if we drew this one or this one, they'd all be off more. This is the least off line, the best fit line. Very, very good question. I want to slap the equation on the chart too, although I don't want to slap. I'm going to format the trend line. Here we go. Let's put the equation on there. And all that I'm doing right now is stuff you guys are going to be doing. Oh my God, how small could that be?
Oh my Lord.
Good Lord. There we go. Let's get a little larger. Okay, there we go. So check out the slope.
1.4.
1.4, 1.45. What's that kind of close to?
1.6.
Oh, say it again. That's pretty damn close to the golden ratio, isn't it?
Yeah.
That's pretty damn close to the golden ratio. It is. Now, why is it pretty damn close to the golden ratio? I don't know. It just is, right? This is one of those things. I heard my foot equals my forearm. I heard that this equals this. It's one of those things. You ever try pants on without trying pants on? Put it around your neck. My mom always teaches me this all the time. Take your pants around your neck. Your neck is, in quotes, half as big as your waist. What half as big as your waist? Now this is back in the day when old guys like me wore pants on our waists and not on our butts. So it may be different now. That might not work anymore. But the idea is there's all these dimensions that are true, like in our bodies, right? And this is one of them. This is one of the ones. Now, it's not perfect, is it? It's not perfect. It's close. Brittany, go.
How far is too far from the golden?
Oh. Thank you. Thank you for the greatest. Next question. You actually segued for me. How far is too far? I said, what is that pretty close to? And a couple of you said it's pretty close to the golden ratio. Who's sitting in this room goes, it's not close at all to the golden ratio. Good! So how do we rectify that difference? We start by taking 5, because it's now 9:05, and we've slammed through this, and we're gonna come back, and I've got a whole bunch of answers for you. Yes, we gotta take 5.
I thought you were going to use 5 for something.
Oh no, and take 5, plus or minus. Right. And we're gonna talk about plus or minus, Brittany, because that's what it's all about, is plus or minus. Thank you, sister. Very good.